Welcome. In this video, we're going to talk about solving compound inequalities. Before we do that, we're going to approach this warm-up problem just as a refresher. Here we have a graph with the solution provided and a bunch of inequalities. We want to find out which of these inequalities will end up with the solution that's graphed above. The first thing we want to do is solve each one for x, so we'll subtract 3x. We get 3 is greater than negative x. We don't like the negative there, so we'll divide by a negative 1. We get negative 3. We flip the symbol because we divided by a negative, is greater than x, or in other words, x is less than negative 3. That is not the graph that's above here, so this inequality will not give us the solution of x is less than 3. Let's go to the one below it. Below it, we have a less than or equal to symbol, which means we'd have a filled-in circle in our graph, and this is an open circle, so we can go ahead and eliminate that as an option before we even solve. In this next inequality, we're going to go ahead and distribute on both sides, so we get negative 5x minus 5 is greater than negative 4x minus 8. At this point, we want to get our x's on one side. There's two approaches. One is to make everything positive, so we could add 5x to both sides. The other approach is to make sure that x is on the left-hand side. Either way, as long as you're following the properties of inequalities, it should work out. Let's go ahead and add 5x to both sides, keeping our x positive. We'll add 8 to both sides to move the constant to the other side. So negative 5x plus 5x, those will cancel. Negative 5 plus 8 is 3. We did not multiply or divide by a negative, so the symbol stays the same. Negative 4x plus 5x gives us x, and negative 8 plus 8, those are opposites, so it's 0. So we're going to change this around or reverse it. So x and 3, the symbol is opening up on the 3, so again it will open up on the 3. In other words, x is less than 3, which is what this graph is above here. So that inequality will give us that solution. And the next one, we've got a bunch of rational numbers here where we're dividing by 5. So we can multiply every term by 5, meaning we'll multiply here by 5, and then as whatever we do to one side, we want to make sure we do to the other as our multiplication property of inequality. We'll state that. So with the 5s, this 5 will reduce with that 5, leaving us with 4x minus 3. The symbol stays the same, greater than 5x minus 6. And at this point, we can go ahead and solve. If we subtract 4x from both sides, we want to add 6 to both sides. 4x minus 4x, those will cancel and give us 0. Negative 3 plus 6 is 3. The symbol stays the same. And then 5x minus 4x is x. And negative 6 plus 6, well, that cancels and gives us 0. So again, we're going to reverse this with x and 3. And again, the symbol is opening up on the 3, so it should open up on the 3, or in other words, x is less than 3, which is this graph above, so this is a solution. All right, compound inequalities. In compound inequalities, we can either have an intersection or a union. In this case, we have a union. We're going to take all of the numbers where x is less than 7, or x is going to be greater than 9. If your answer is 10, it satisfies one or the other of these inequalities. In interval notation, we want to start with this very smallest number, which is, this goes backwards forever, or negative infinity, all the way up to 7. Now, infinities always get the parenthesis, and this is not included, so we're going to put a parenthesis. And we're going to pick it up again, so we're going to use the union symbol. And at 9, but we're not going to include 9, all the way to infinity. And again, our infinities always get parentheses. This, again, is a union problem. So we're going to go ahead and write the two inequalities where we have x is less than or equal to negative 2, or x is greater than or equal to 2. In this situation here, as in interval notation, we're going to go ahead and start with our smallest number, negative infinity, go all the way up to negative 2. We include that, but we don't always parentheses around the infinities. Pick it up again at 2 to infinity, and 2 will be included, and infinity always gets the parenthesis. This problem here is an intersection. It takes what's in common between the two inequalities. So there's a couple of ways we can represent this. One is we want to say that x, and we'll start with the 10. X is less than or equal to 10. But also we want all the values bigger than 6. We can go ahead and write this where the x is bigger than 6. This is an abbreviated compound inequality. We like this because it's concise and we know our numbers are between 6 and 10. When we write this in interval notation, we're going to go 6, 10, and they're both included, so we'll include them like that. In this case here, we're going to have all numbers between -3 and 1, with the 1 being included. So we're going to say -3, the x is going to be bigger. So x, if we read this backwards, says x is greater than -3. And then also at the same time, x is less than or equal to 1. In interval notation, we've got -3, 1. If we choose a value or a solution x, let's say 0, it will work in this inequality here. So let's take a look at what it looks like to graph the numbers, graph the solutions. If we have an AND situation, we want to find the intersection, what these numbers have in common. So here we've got 5. We put our smaller number to the left and our larger number to the right. And 5x is greater than 5. So we put an open circle on 5, and we're going to start shading greater. But we want to find what they have in common. X at the same time has to be less than or equal to 9. So we'll put a filled in circle there, and we're going to go less than. So if we're to find what they have in common, it's this region in between that they have in common. On the other hand, with an OR situation, we're finding the union. We're going to take everything that we possibly can. So we put the smaller number on the left, larger number on the right. X is less than -7. We're going to shade all numbers smaller than -7. And at the same time, we're going to do x is greater than or equal to 0. We'll shade all the numbers to the right. So as long as your answer is in one of these shaded regions, it will be considered a solution to this instead of compound inequality here. Again, with the x being in the middle, this is an intersection problem where we want all the values between -1 and 6. So we choose -1 and 6. Here the -1 is included, so we're going to put a closed circle on there, and the 6 is not included, so we'll have an open circle, and we want the values less than 6, but at the same time greater than -1, so the region in between. When we're solving compound inequalities, we simply solve, in the OR situation, we solve both inequalities and then graph our answer on the number line. So for this situation, we add 8, we'll add 8, we get 6x is greater than 12, divide by 6, divide both sides by 6, and x is greater than 2. This is one part of our compound inequality. Then we solve the other side of that. So we solve it independent. We'll subtract 2. We get 6x is less than -6. Divide by 6, and we get -1. Notice our symbol stays the same because we did not divide by a negative. Our answer is negative, but it still stays that same symbol. So when we graph this on our number line, we put our smaller number to the left, our larger number to the right, and we want values x greater than 2, and our numbers x is less than -1, and so there's our solution. In this situation here, with x being in the middle, kind of smashed like a sandwich, we're going to go ahead and whatever we do to the middle to get x by itself, we do to all parts, so to the left side and the right side. So when we add 7 to solve this, we're going to add 7 to all 3 parts, or in between these inequality symbols. We get 8 is less than -2x is less than 14. When we divide by a negative here, we have to flip all of the symbols because we're dividing all parts by the negative. So we've got -4 is less than x is less, oh, I apologize, we've got to flip those symbols. So it becomes -4 is greater than x is greater than -7. When we have a compound inequality like this, just like in interval notation, we want to go smallest to largest. So we're going to say -7x -4 is the larger number. In this inequality, the inequality symbol is opening up on the -4, so we're going to go ahead and open up on the -4. Here we're opening up on the -7, or on the x, excuse me, so we're going to open up on the x. And now when we graph it, it's a little clearer where we're going to be graphing. Our smaller number is -7, our larger number is -4, and then we're going to do all the values in between. Alright, so that is how we solve compound inequalities. You've got some practice problems that you can try. with solving compound inequalities, and then we'll come back together and talk about special cases in the next video.